Ever built a program, put in some data, and then you close it? And you wonder, where did all that information go? Well, today we're going to talk about Java file handling. This is the key skill that basically gives your programs a memory. So let's get right into it.
Yeah, let's start with that big question. You run a program, right? It does its thing. Maybe it crunches some numbers, you type some stuff in, but the second you hit that X to close the window, poof, it's just gone.
And that's because, by default, a program's memory is, well, it's temporary. It only exists for as long as the program is actually running. The moment it stops, it's a complete clean slate. I mean, it's like it has total amnesia. So we're calling this program amnesia. And honestly, it's a massive limitation. I mean, just think about it. A game that can't save your high score, or a text editor that forgets everything you wrote as soon as you close it, that would be pretty useless, right? We've got to find a way to make that data stick around. And this is exactly where file handling comes into play. It's like the superpower we give our programs so they can actually remember things. It lets our Java code reach outside of its own little temporary memory bubble and talk to the files on your computer's hard drive. It's the bridge that creates a permanent record. All right, so let's start with the first half of this equation, teaching a program how to read. How do we get our program to pull in information from a file that's already sitting there? Like a config file or maybe a list of usernames. So it turns out it's a pretty logical four-step process. First, you have to point to where the file is. Then you grab a special tool called a scanner to read it. After that, you just read through it line by line. And finally, and this is super important, you have to clean up after yourself and close that scanner when you're done. Okay, step 1. Tell Java where the file is. We do this by creating a file object. Now, you can think of this less as the file itself, and more like a map or maybe a signpost. It doesn't actually hold the data, it just holds the address, in this case, sample.txt. So Java knows exactly where to go look. Next, we need the right tool for the job. And for reading, that tool is the scanner class. So if the file object was our map, think of the scanner as a special pair of glasses that can actually read the text at that location. We hand our scanner the map, and it gets ready to do its thing.
All right, step 3 is where the real work happens. We use a while loop that's constantly asking the scanner, hey, you got another line for me? As long as the answer is yes, as long as scanner.hasNextLine is true, we grab that line. And once that loop is all done, it's absolutely crucial to close the scanner. It's like putting your glasses away when you're finished reading. You're releasing that file so other programs can use it.
Okay, so our program can read. Awesome. But what about going the other way? How do we get our program to create its own information and save it to a file? Well, now let's talk about teaching it how to write. And you probably noticed this looks a lot like the process for reading, which is fantastic, right? Let's remember. We figure out what data we want to write, we grab a specific tool for writing, we use that tool to actually write the data, and then, and again, this is so important, we close the writer to make sure our changes are actually saved to the disk. So instead of a scanner, our tool for writing is something called a FileWriter. You can think of this like telling Java, hey, I need a pen and a notebook, and I want that notebook to be named output.txt. And what's cool is if that file doesn't exist yet, Java is smart enough to just create a new one for us. And the action itself, it's beautifully simple. Once you've got your FileWriter, you just use the write method to put your data in. But, and I can't stress this enough, after you are done writing, you have to call writer.close. That's the step that actually saves the changes and releases the file. Forgetting to do this is probably one of the most common mistakes, and you'll end up with an empty or an incomplete file. So let's just do a quick recap here. When we want to get information into our program, that's reading, we use a scanner. And when we want to get information out, that's writing, we use a FileWriter. Simple as that. Two different tools for two very related but distinct jobs.
Now, in a perfect world, that would be everything you need to know. But we're programming, right? And things don't always go according to plan, especially when we're dealing with stuff outside of our program's control, like files on a hard drive.
So what if the file just isn't there? I mean, this is a classic problem. What happens if your program tries to read, say, config.txt, but the user deleted it? Your program is going to try to open something that doesn't exist, and, well, it's going to crash hard. This kind of error has a name. It's called an exception. It's basically an exceptional event that disrupts the normal flow of the program. And for our missing file problem, Java has a very specific name for it, a file not found exception. We need a way to handle this gracefully instead of just letting our program die. And here is our solution, the try-catch block.
This is like a safety net for your code. You put all the risky file stuff, the code that might fail, inside your try block. If something goes wrong, instead of crashing, Java catches that exception and runs the code inside your catch block instead. You can print a nice error message or something. And by the way, a more modern way to do this in Java, called try with resources, can even handle closing the file for you automatically, which makes things even safer.
Okay, so we've learned how to read, how to write, and how to handle errors when things go wrong. But where do we actually use this stuff? Let's take a look at some real-world examples, or as I like to call it, files in the wild.
When it comes to reading, honestly, it's everywhere. Your favorite application probably reads settings from a config file when it starts up. A game might load level data or character stats from a text file. And if you're a developer, you're constantly reading log files to figure out what went wrong.
And on the writing side, it's just as common. Programs are constantly writing out log files to keep a record of what they're doing. Maybe you've used a feature to export your data to a .txt or a .csv file. That's file writing. Or maybe a program generates a big report and saves it as a text file for you. All of that is file handling in action.
So here's the crucial point, the big takeaway. File handling is what takes a program from being a simple temporary calculator and turns it into something persistent. It gives your software a memory, so it can remember things, and it gives it a voice, so it can communicate with the outside world.
It's a really powerful concept when you think about it. Just by learning how to read from and write to files, you've totally unlocked the ability to build much more complex, much more useful applications. So I guess the only question left is, now that your program can remember and speak, what are you going to build?